Lesson 4, topic, medians and altitudes. Learning target, I can use medians and altitudes of triangles to solve problems. Median of a triangle, it's a segment from a vertex of a triangle to the midpoint of the opposite side. So here in our triangle, a vertex would be one of the endpoints. So here, here, or here. And then drawn to the midpoint of the opposite side. So right here would be a midpoint, and then we would know that that and that are congruent, those two segments. Centroid is the point of concurrency of the medians of the triangle. So this point where they all meet right there in the middle is the centroid. We also call this the balance point because, fun fact, if you construct the centroid of a triangle and then balance it on your pencil, it will stay balanced. Concurrency of medians of a triangle. So the relationship here is that the medians of a triangle intersect at a point that is 2/3 the distance from each vertex. So this point to this point would be 2/3 of the whole median. So if we try to draw the whole median, so the orange is 2/3 of the blue, which then also means there is that opposite relationship of then this piece, this green piece right here would be 1/3 of the blue or half of the orange. So there's lots of different relationships in there. It's working a lot of your fraction skills here in this lesson. So in triangle, RSTQ is the centroid and SQ is 8. So SQ is 2/3. So if we break that down into 4 and 4, 4 would be 1/3 of it. So then that means this piece down here is also 4. So we know that QW is 4, and then SW would be 4, 4, and 4 is 12. You can also check to make sure that SQ, this piece right here, this 8, is actually 2/3 of the whole. So is 8 equal to 2/3 of the whole 12? Well, 2/3 times 12, we would do 2/3 times 12 over 1. 2 times 12 is 24. 3 times 1 is 3. 24 divided by 3 is 8. Does 8 equal 8? Absolutely. So then our next piece, another example, point G is the centroid of triangle ABC. Solve for X using the information below. We have FG, this piece right here, is equal to X plus 8. And then we have AF, so the whole piece is equal to 9X minus 6. So in this part, we're given that this is like the 1/3 of the whole because it's the piece at the end, because this piece up here would be the 2/3, which makes this piece down here 1/3. So we know that FG is equal to 1/3 of AF, the whole. So now we just have to plug in our pieces and solve our equation. So FG is X plus 8 equals 1/3 times AF. So make sure you put that in parentheses because it is the whole quantity, AF. And now we just need to solve. So to solve, we're going to start with distributing that 1/3. 1/3 times 9, so it's just really dividing 9 by 3. 9 divided by 3 is 3. 3x minus 1/3 times 6, or 6 divided by 3 is 2. So now we have this equation that we can solve. We can draw our line. We want to get our x's to one side and our numbers to the other side. So I'm going to start with subtracting x on both sides. X minus x goes away. 3x minus 1x is 2x. And now that I've gotten my x's to one side, I want to bring my numbers to the other side. So I want to undo this minus 2 with plus 2 on both sides. 8 plus 2 is 10, and negative 2 plus 2 is 0. So we have 10 equals 2x. Very last step is to get x all by itself with division. Divide both sides by 2, we get x equals 5. Now you can always check your answer to make sure that it is correct. So you can plug x in here and make sure that that relationship of the 1/3 to the whole actually stands. So if we put x in for FG, we'd have 5 plus 8. So FG equals 13. And then if we put 5 in here, we'd have 9 times 5 minus 6. 45 minus 6 is 39. And yeah, 13 is 1/3 of 39 because 13 times 3 gives you 39. Last piece here is just altitudes. We're not going to do a lot with altitudes, but just to be aware of what an altitude is. Another word for altitude of a triangle would be the height of a triangle, which you've probably seen in area formulas like base times height. But the altitude is a perpendicular, so makes that 90-degree angle. Perpendicular segment from a vertex to the opposite side of a triangle. It could also be a line containing the opposite side of a triangle. And then the orthocenter is just the point of concurrency of the altitudes of a triangle. There's no special relationship there. It's just making sure you know that that's what it's called. And then lastly, just to make sure we can differentiate between the 4 different types of segments that we've learned, we're going to identify whether YW is a perpendicular bisector, an angle bisector, a median, or an altitude of the triangle given. And just note that there may be more than one right answer. So if we look at the first triangle that we're given, we're told that YW is perpendicular to XZ. So we know that this line is perpendicular. We are given no other information. So we know that it is from a vertex and it is perpendicular. So what we can say is that this is an altitude. We know nothing about the bisector piece, so we can't call it an angle bisector. We don't know anything about the angle measurements. Only thing is that this is 90 degrees, so we don't know that it's bisecting angle XYZ. We don't know that it's a median because we don't know that W is the midpoint. All we know that it's perpendicular from a vertex, so that makes it an altitude. I'm going to go down here to this one, and we know that angle XYW, this angle right here, is congruent to angle ZYW, which is this angle right here. So we know that YW is bisecting angle Y, so we can say that it is an angle bisector. And there's a typo here, so we have a repeat. So we're just going to cross this one out, and we're just going to do the last one here. We know that YW is perpendicular to XZ, so we can make that 90-degree marking. And then we also know that XW is congruent to ZY. XW congruent to ZW, excuse me. So we know that W is a midpoint, and we know that this is perpendicular. So we can say, one, it's a perpendicular bisector because we have perpendicular and it bisects the segment XZ. We can't call it an angle bisector because we don't know that it bisects the angle, but we can also call it a median because it stems from a vertex to the midpoint because we know that W is the midpoint because of the congruent pieces. And then we can also call it an altitude because it stems from a vertex and is perpendicular to the opposite side. So sometimes it's only one and sometimes it can be multiple things. I apologize for the length of the video, but I hope that this was helpful for your learning and you can go ahead and move right on into your practice.